So this is the part 2. I just continue the building of the gifts app. Watch the previous version to find out how we've built some routes in the gun-vue app. So we have the list of gifts, and this list is synchronized nicely. So if we go to another browser, so everything is loaded here via this peer, and I can use a local peer or any public peer. And let's say I have this good boy sending a 100 US dollars for your pleasure, and it is sent. So we propose it, but the thing is that anyone can propose something from anyone else. So just like here, I'm not logged in, but I can come here, say that I'm gifting a 1,000 for best, and yeah, it's added. We can see it here, and yeah, just there is no from field at all, so it's just 2, and this means that there is it may be full of crap. So it will be full of crap because it's public graph, but it's immutable public graph that may be verified against some rules. So my idea is to make this graph so we should have this signed, so not just the hashed, but signed also. So let's go and see what's hash obj about. So hash obj, yeah, so it is when we have the hash text see work. So yeah, so we have just JSON stringify, and then we have it hashed with a cwork. Okay, and what do we need? We need to have the object stringified, so we will have the hash text itself, because what we will have to do is that we will have to say that signed is just so we will have the JSON stringify, and this will be the gift that will be stringified. Then we will say that this is string. Just first, this is the string. Then we need to sign it. So we say that signed equals await c dot sign, and then we have the string and the pair that will be user dot pair. We know that this should work if we have the user, and we have the user here, so this should work. And let's just console log this signed message and won't put it anywhere. So just let's see what is it to have this message signed by us. So let's see, we have 2,200 US dollars like this, and 4, yeah, and propose. And what do we have? We have the CM, then we have the data, and then S, we have the signature here. So we have the data and the signature. I like it. I like it. So what does it mean? This means that we have it signed once. So we can verify this by the field of from, and then decide what to do next. So okay, let's take it like this. So we go to, so we hash not the gift but this signed, yeah, this signed string, and yeah, and then we have it stored in this immutable list and at user place, so at the user space, of course. Okay, that's okay. Now then we can say that here we have at index view, we don't need this del button, but we will need so yeah, now we have the gifts, just so del isn't, we don't need it. Yeah, what do we want to do? Okay, we have all the gifts listed here. So on the main page, let's remove it from the add page. We have the proper list page. Okay, and this gift should go right at the top. Right, not at this top, but here, maybe here it should go. Yeah, so we will see it, and that, yeah, it's filling up with data, of course. Okay, and then we'll send it. So we send it propose, and here we have the gifts, and we've set the function propose, and we should have that signed data. But no signed data. Okay, let's just gun get prefix get hash hashed. Oh yes, it's hash object, and we need hash text because we already have the text, and yeah, we have the hash, and so we have this signed here, and this is equals and hash text. Yes, yes. So now we will have the data. So USB, okay, and propose. Yeah, we click propose, and here we should have this signed data. Yes, here we have it. So it's there, but it's not so easily decoded with the JSON parse. It's not a JSON, it's C-signed JSON. So we need to verify it first in order to be sure that we will display it. So for now we try, so use gifts, and we have the async function here. So this is async, and we will say that first we will try to let's const verified is c verify, and there's the message and the public key that we should tell here, place here. So verify d with, and we will have to get the data out of the message. So let's say for now it's an empty string, but we will have to just if d starts, if it should be JS string starts with, it should be, how does, yeah, starts with search string, yeah. So if d starts with c, then we should just verify it and and console log, you know, like C. Okay, let's move stepwise. So C, there it is. So here's one of all of these. It's not shown because we don't have the parsed, the string parsed, but we have it. We have it here. We know that there is something to verify. Okay, we will just splice, I believe. So let's say that object is yeah, so JSON is let's say signed is like d dot slice start, yeah, just start, and let's see this signed message. So we're loading. Yeah, it's JSON parsable. So signed is okay, and we will say that the JSON is JSON parse signed, and then M. So let's see the JSON. Yeah, it's working fine. So we got the object. We have some errors already, but everything's working till now. Okay, so we got the JSON, and so we can have the from. So from, and we can verify with this from. Yeah, like this. And let's console log, let's say info, and say verified. Okay, now we have await. Yes, so now we have the verified. So these are the line 49 and this is 50. So the verified version is exactly the same as the JSON that we've extracted, but we need to do this to find out this from this pub key. So we can verify. Now we can verify and say that yes, this is verified. If we have incorrect public key, so this will be undefined, so no verified data. But we have the verified data, and once we have it, we will say that this gift is verified. So this verified is the gift that we need to add. Yeah, so now we will have one gift here. Yes, and every other records are just filtered out. So now we can say that this gift is signed by one party, and that's for sure. So we know that the one who have sent the gift, he has it's certainly that he is the author. So now we can have just this list, and we can have the record of from. Yes, so from. Yes, we know that this from is always right. Let's say that it's account page with pub like gift from. Yeah, so here is the from data. Let's say it's flex auto. Oh, it's let's should it be like it was. So now we have the gift information. Let's say it's flex, and here we have flex 1 and the data. So here is the account, and I should yeah, it's now it's fine. Account avatar, yeah, like this, and the size. Yes, it's fine that we just have the avatar. So from here we will have this will be M4. Yeah, so we will have the gift information, and we know that it's from, certainly from this person, but we are not sure that the receiver knows about it and is happy about it. So let's think about what how can we save this contract like an interaction. So not only one party verifies that it's that proposal, it's that 100 USD that's proposed on that date. So we should of course have have the date, so we should have the date, and this should be computed. Oh no, yeah, but maybe not a computed, but it should be used. Oh, it should be use now. So we import this use now from VueJS, and let's see if it will work for us. So add gift, we have the date here, like this. So maybe it's okay, because let's just create another USG proposal. So we've proposed another gift, so we have some data. Yeah, there is the date. So we know this date it's readable. We know this is UTC, this is universal time. Yeah, and it's 1711, okay. And it's the date. It's not a Unix timestamp. Maybe it should be a timestamp, but it's more readable. It's more readable, and it's quite nice. Okay, let's have it like that. So here's the date, and now every time I press it, there will be another and another and another gift, that proposition, many. So many. I will say that, hey Pale, can I have 3 propositions for you? Yeah, and here are all the 3 of them. So the avatars are a little bit smaller. Let's say that mean width is 100 pixels. Maybe it should be 50 pixels. Okay, and let's say it's just 50. Okay, mean width is 50 pixels. Yeah, so here we have the date, the from, and it's verified. We don't show gifts that aren't verified, but verified by the ones who've sent them. But now is the thing, this cannot be a synchronized process. So one person proposes a gift, then another person should approve it, and it's deferred. So we don't know if the person will approve and which of these random proposals will be approved, and it should be approved once it's just received. So if someone is proposing a gift, he will get all the information about the payments, about how to transfer it. He should have that information, and then so this user has the proposition. He knows that it's saved, it's verified, and then he transacts. He makes a transaction. So we may ask the receiver, have you received this? And he will say, yes, I've received it, thank you. And this thank you should be stored so we can verify if this transaction from and to was successful, and if this to is really the to that I suppose. So the thing is that it may be built with just 2 layers of signatures. Yeah, it's just, I think that's simple. So we can just unwrap the gift, so we can verify the string that we get from the immutable storage in Gun database, and we can verify it. And if the verified string is, again, starts with C, so we know that is verified, that is signed twice. And if it's signed twice, then we know that this gift is really approved. So we may say that we can have like 2 graphs, immutable and public graphs. One for propositions, where we have the once signed gift propositions. So it's like, not meaning too much, and we may make the proposition transport, like we may send the propositions directly from one to another, but then we will have the storage for the real gifts that are that immutable transactions between 2 parties. Yeah, I like this. So we will say that till now we've built the proposition system, and this means that gift propositions, gift props. Okay, so now these are the gift props. And yeah, just changing one thing, I've started a new new list. Let's go to the gifts. Yes, we have the gifts. We have the gifts here. Yeah, with all the information. So these are propositions, and we should know how to deal with them with another user. So we get to the point where we should have 2 users. Yeah, 2 users communicating. And yeah, let's say that these should be propositions. So let's say that here in the index we know that these are propositions. So like yeah, we have this part, and this will be text LG font bold. These are propositions. Yeah. So here are the propositions, and we will have to get the 2 data. So we have from. Let's take the 2 data, and so this is flex. Let's say we have this flex auto. Okay, this will be font mono. Yes, the space, and text SM, small text. Yeah, and above that we will have account avatar, and the pub will be the gift 2. So here is the 2. We know that it's for this user, and 4. So it's like 4 something like this. Yeah, P4. So yeah, we can have gap2 like this, and yeah, and P2. So this is the 4, and we have the user who is receiving it. And let's show let's show the flex, and then we will have the flex call. Then we will have text XL. We will have gift QN, and then we will have like flex call, text LG gift QL. Yeah, then it will be gap4, it will be text bold, a font bold, and yeah, it should be P4, okay, like this, and this should go there. So this is flex. Oh no, this is not flexible, and let's save it for now like this. So here are the propositions. So we need to know that these gifts are propositions, and there will be real donations or gifts. Like I use gifts for it to be shorter, but it's donations the same. Okay, now we have the gifts and the propositions. So use gifts, we have the prefix gift props. So these are the propositions, but maybe we will yeah, we should use propositions and also use gifts. So okay, let's duplicate, but maybe we will extract some functions. Okay, on async. So this may be just an unwrap once. So cut the first 3, then parse the JSON and have the data, then verified by the from, verified. Okay, but let's use it as it is. The thing that we need to do here is that we will have the prefix like here we will have the gift will be the prefix. No, let's say the prefix is the gifts like this, but then we have like the place where we save the exact like transactions. Like let's say for now, okay, let's say transactions will be gift transactions, like this, gift transactions, and we will get here. So we have transactions. So these are the gifts, the real gifts, and these are proposals. Use props. Okay, use props. No, not use prop. Use gift propositions. And this should be propositions and propositions, like this. Still should work. Everything should work, yes. And we will say use gift propositions. Use gift propositions. And here we have propositions, and we will list these propositions, and everything should display as before. No, it's not propositions. Propositions. Yes, we got the functions back, but these are gift propositions. And yeah, we will just if there's proposition to me, then I can sign it and make it real thing. So these are so we should have the component for the gift to display it, as it is just a schema. We know what it is composed of. Let's bring it here. So again, we have the three layers: composables, components, and app. We will have some components. Now we will start from adding a folder named gift. Then we will have like some file here that will be like card, like it should be gift card, I suppose, but for now it will be card. It will be card because we are creating the data from the folder. So log3 gift card from link and so on. So gift card is a Vue component that has this data inside. So account avatar. So yeah, pretty much everything here should go into the gift card. Only this v4 will be outside, and also we will have props that are define props, and then we will have the gift as type will be object, and default will be an object with qn0 with ql empty with wish empty with the from empty and to empty to. So this is the starting point of our object gift. So we have all these parameters here, and here we will have all the information we need, like from saying that we will have gift card, and say v4, we have all the things, and we will have gift is this gift already. Okay, but now this won't work because the system doesn't know about this component. We will need to find a way to implement it. So here is the list of all components imported. I don't know how to make it a little bit more easy and fun, but maybe we should just move it to the index files in every folder and then import all the folders as we have for the composables. But for now, let's say these are gifts, and let's export default as gift card from. Then we have the path there, so it's card.vue. Yeah, this is what we need. File name, account. Let's see, account. Let's change. Yeah, this is the problem with the letters. I don't know if I should just rename everything to be lowercase, or I don't know. There's account avatar. Okay, but everything should work. Let's restart the app, and it should grab the component. And yes, we have the components nicely. So these are the propositions, it's reactive, and here we have the data. Yeah, we can change it live. So now we have the gift card component. Let's make it a little smaller, like, yeah, so this will go here. Now we have item center like this. So this is the record, and the thing that we need is date. There should be a date, and there should be a wish. So let's say the wish like here, and let's say that if gift wish, so if it's there, but maybe it's not there, and it will be p0, okay, p2 like this, and p2, but this should be inside. Okay, let's see if it will fit inside. Okay, for now it's really okay, but on small screens it should, of course, wrap. Yeah, and it should be fine, and we will have the date. It should be everywhere, but we have some items missing the date. So from, and what, and for whom, and why, and when. This is the information we can get from the gift, so we can forget about showing every information. So like text, should it be no, it won't be smaller, but when if we will have this avatar smaller, we can have like flex auto, like flex 1 Yeah, so we have the list. These are BG opacity 990 rounded, XL and BG light. So shadow will help us see all the so Ngap2 will make us see all the gift cards. So here are the propositions, and we won't need to show them all. So it should be parsed internally, and we will just look for those that are supposed to be ours. So it's for us, for this user. So there should be my gifts and propositions, and there should be like my propositions and propositions propositions from me and propositions for me. So to me too. So okay, now we can react to this proposition. So for now they are all listed. Okay, and let's say that if we click we should have the button to approve, and we need a function for us to approve some gift by its hash. So it should be nice if we can just have a function that will approve the gift. Let's go to the composables and go to the gifts and say that there should be gift propositions. So we have the propose here, and this is about a gift. So we should have a function accept gift, and there should be a hash of it. So what do we do with the export? We export this function, and let's console log the hash for now. Yeah, with it we have this accept. Yes, we couldn't we don't need the log, console log, it was a mistake. Yes, so we should have accept gift. Here we will import accept gift from composables. Yeah, and there is no function here, so add click accept gift, and we will have the hash from here, and accept undefined. Yes, so we will need the hash too. So it's a string, and we will have it here. So hash is hash. Yes, so we have the hash, and there yes, so we have the hash, and we know that if we accept it, we get the hash we needed. So okay, we know that we have the hash. Then let's say that let's rename this symbol to proposition path, propositions path, like this, and this should be like gifts path. So gifts propositions and gifts accepted, like this. I'm trying to not to pollute some nice namespaces and use some weird ones, just to have some space to experiment and not ruin all the spaces, all the good names with some crazy naming. Okay, I don't select myself, so Fern, so 100, so you Australian dollars, so Australia, so I propose it, and then I have this proposition here, and I'm clicking and I have the accept, but let's see that we have here the propositions, and this means that this number, this button should show if, and we should say that gift 2 is equal to user pub. So we have this user again, and this user is we can get it from use user, from this object is user. So here's the user. It should appear like this, and now we will have to log in as a person. Okay, it's to Fern, and the Fern is I should, okay, so this chick, so chick is here. Here's her avatar, and now we can add a gift to this user. US dollars, US followers, and yeah, we propose. Yeah, here it is. Now this proposition may be accepted, and if I press accept here, I will have the hash printed into the console. Yeah, here is this thing. Okay, this means that the propositions are public and everyone can create one, and with the growth of the number of the propositions, we will have to parse all of them and verify them and find out, but maybe not verify, but first we will cut the C and then JSON stringify them all. It's a huge task. It's a huge task once it gets bigger and bigger, and yeah, it's a thing that we should note, but I think that it can be mitigated with buckets. So we will have like propositions of this week, and once the week ends, we start another prefix for the week, and so we will have weekly propositions and weekly gifts. But maybe gifts shouldn't be built like this, because they are final things about the transactions, and even if there will be like a couple of million of gifts, once we check, we won't load them all. We will load only some of them, I suppose, because we can just check if the string contains a certain pub key, for example, or a certain from and to, like or like money, or a wish, or so from or to, or what's more important, the project that will be like the thing about the thing that will make this donor pay some money to this receiver. It's not just random idea, it's because this person is building something very interesting, very nice, like a video blog maybe, but maybe some thing, maybe some other project, maybe art project. And so this user will send some donations to this maybe artist, maybe builder, maybe maker, maybe someone who he appreciates and want to share some wealth and value with this person. So there will be information at which we will filter everything out. And yeah, for now, the last thing I want to implement for this to be like a MVP project is that we will have this accept button working. So we will have gifts that are accepted by both parties. So it won't be reversible. If you press this, then an immutable record will be saved into this path, gifts accepted. So gifts accepted, and these gifts will and there will be a record that will be signed by both of the parties, and that will say that yes, this proposition was accepted, and finally it's verified. So one thing to play with is not to store the whole object and have the problem of parsing it twice, but we may have at the gifts accepted just the hashes, so we can have the hash signed, and that's all. And once we have the hash signed, we can also always check if if the to field of the initial proposition does verify this record. If it is, so we know that the initial proposition is fulfilled, and this information is stored not at some user space, but in an immutable space that everyone can add to, but no one can delete anything. And I think that may be quite useful. Yeah, there may be some spam, but we just can verify it. We can do it. If it's polluted, we can just change these paths and start over. But the data may be easily transferred, because we can just so the record about the acceptance of the proposal may be written by anyone. So if I have so it's not that. So yeah, I can verify that data, that hash, but this text may be pasted, may be entered, may be edited by anyone. But let's try. I don't know, maybe it should work, but maybe someone will help me with updating these algorithms. Okay, for now we have the button of accept gift, and we just print the hash of it. So let's try and just go to let's get a gun instance. So it's always nice to have a fresh gun instance. It's very cheap to get, so no worry about the memory. And then we go gun of course, get gift, how is gift path with the hashtag. Yeah, I should use template literal, but everything is crazy, but it works. Okay, and then we have we can set. Okay, we can get some hash, new hash, and put some hashed. So these are the results, but before that we will we have the exact hash, so let's go and get gift proposals or something like that. Proposals path. And yeah, of course we will have proposals path will store the hash sign inside. It's really easy to make it like so. It was a temporary solution, so yes, now we have the gift propositions like this, and not found get on use gifts, of course, because we don't need to load the get. It was a so page.js response. Okay, we have the gifts, and we have the gifts back here. We have the accept button and reference error, and yeah, so now playing pressing accept gift will give us some errors because there is no G. Yeah, so of course there is no G because we get the propositions path. Then we get the hash, and then we once we get it, we will say that the data should be console logged, of course, the data. Okay, that's nice. So we accept. What's the problem with requested fit external? Okay, we have this auto imports that we don't need. I don't know why it's happening. Yeah, so we have this accept button, and we have, yes, the string of data that we need. So here is the proposition. So we know this proposition, and do we need it? Yeah, we should check if it contains our pub key. Should we or shouldn't we? Yeah, we have the hash. Yes, we have the hash, and we have the contents. But really we will need to just say the gifts accepted like this, gifts path. Okay, now we have the hash, and what do we need is to work with the hash and sign it. Let's try to sign it. Yeah, so it's the second part, like we have the gift propositions and the accepted gifts accepted. So these are two parts of all we need. And here is the body of the gift, and here is the verification part. Okay, let's try it. Yes, so we have the hash, and we can just say that signed hash is await C sign. Then we have the hash, and then the user dot pair. So we should have the user, use user. Yes, we have user here. We will need to get the user here, and yeah, so it's always this fresh user that we're using now, that is current user. So we have the user and the hash and signed hash. We will put it, so we will say that we will get the sign. No, we will. No, it's not finished. So it's signed hash, but then we need to signed and hashed is await C await hash text and signed hash is the thing that we enter here. So we will have hash sign, like yeah, hash sign, a little bit confusing, but maybe I'll find some better naming later. So, and there we will put the signed hash. Oh my god, yes, we have it right, but the auto import is still struggling. Yeah, now we have this button, and yeah, it happened. So now we have gifts accepted, and here is this hash that is signed. So this is the acceptance of the gift that is here under this hash f2 TPV, so f2 TPV. So this gift is accepted. So here's the proposition with all the data, and here it is accepted. There is no place for any other data, just the hash. But maybe we can save it as a document, like more like an object. So we will have the date of acceptance, and we will have something more, and the thing is that we may also have not just here. It may be that we may have the initial hash, then I'm sorry for this simple strategy, no, not using template literals, but let's try it. If this time we click accept, data not the same as hash. No, this is we need that the hash is here, but we may have I'll need to check the C work, or so these are gun APIs. This should be maybe here. Verify, no. So certify, or some, I don't know if so let's search for content really gun API content addressed. So I don't remember what, why, how. Yes, so why and how, and guides, maybe guides. I don't remember the content addressed, where we should find it. Oh, sorry for okay, let's search for it in Google. Content addressing. Yeah, so we should put the hash, and or we can get using red, so we can have a search word. So let's try again, but use the hash sign plus hash sign plus. Maybe this may work. Let's try it. Refresh. Yes, there is no error. And let's see if we have gifts accepted. So we have, yes, we have the initial hash, and then we have the hash for the signed hash. But this time we can also sign something else, maybe. But no, this is easily indexable and searchable. So once we have the gift proposition, we know that we can find all the accepted records of acceptance. Maybe it's something like this. This is the place where I can find a really nice simple solution, because sometimes I think that we should just have another layer of another signature around this, and just have a new hash for all the data, and this will be fully self-verifiable. But I start thinking about duplicating data, so we don't need to duplicate this data. We have it already in the graph, so we can link it. So this is the link. This is the verified link to the to this mutable object, and it's already signed. But the idea of interconnectedness, but losing connections, losing data, losing part of the graphs is important too, because in this case we just have two lists. They will be huge, but they will be just plain lists that may be parsed as we wish, and we will have all the propositions and gifts on every client. So any client wants to see what's going on there, they will load it and they will share with others all the full information about the gift. This is a problem. This is an interesting question to think about. Yeah, and this should work. This should work now already. So we can start and continue building the UI without thinking about what the internal structure is, because once we have everything in this useGifts.js, we can change it, and the UI will be just separated from it. It will just use some basic functions, and then we will transform these functions inside of our composables functions. Okay, and yeah, so what's important now is to show not only the propositions but the gifts themselves. So let's say that we will have something like this again, and we will have like accepted, and here we will see that we will need use gifts, like basic gifts, use gifts, like this. Yeah, and then we will have the gifts here accepted. So now we will have an error, maybe. Oh no, we won't have an error because everything is just a copy for now. So it's the propositions path, but we will say this is the gifts path, and there will be some errors, yeah, because we have just some hashes there. Okay, so we have try. We will just console log the D and the K. Okay, and let's see what we got from there. Cannot read. Okay, some errors, I will check them later, but yeah, use gifts, line 84. So we have the D and the K. So the K is the hash and the D is the so the accept makes us accept more and more. Why does it look like so? It should, it should accept it once. Let's see, what do we have in gifts accepted? Okay, yeah, so signing is always new. So anytime I have the same hash, but when I sign it, I get different signatures. And it's elliptic cryptography. It's really powerful, so no one can just guess or use the known string, the known pair of data to extract, to sign anything else. Okay. This means that once we have the propositions, we even can add at any moment any number of propositions. So it's really spammy now. So just start clicking the button, and there will be very many of those propositions. Yeah, okay, and also there will be many acceptances, and I need to know that the acceptance should be just done once. So we will have a user telling about the acceptance of a gift inside their graph or not. Yeah, so we have some part of it going. We have we know how to use gun and some ideas about content addressing. Yeah, it's now time to just chill out a bit and think about it a little more and find the ideas. How can we create these atomic, not blockchain, but atomic transactions, really lightweight and easy for the users to do, and for others to navigate if we want it. Because once we have these transactions going, and they will be open, and they will be just for not a humankind or an account, but for something, for some project. So we will have 100 Australian dollars for a project, for this through this account, and then we will have the statistics about all the donations to all the projects that are listed. Yeah, so looks pretty crappy now, but you see that there's so much peer-to-peer functionality and the graph system inside, and we are building it step by step. So stay tuned till the next session. Now I will just build the app and deploy it for you to play, even if it's such a such a strange thing for now. But other functions are already there. They are working quite nicely. You can, once we are online at the same time, at the same relay, we will share all the information with each other, and you will see my articles, and I will see you in this endless space for us to explore. Yeah, it's really fun. Yeah, some drawings here, and you can add your drawing and yeah, have some fun. Even browsing to the gun-vue page, I will hopefully see these drawings. Yeah, here are the drawings of those accounts. Yeah, it feels like magic. And once I erase everything is erased. Yeah, really fun. Okay, that's it. I'll see you next time. Bye.